Hi there, afternoon. I think everyone loves a late afternoon environmental session. So I'll try and keep it cheery. Thank you very much for having me. My name's Jonathen Arul, and I live and work in Tanzania, and I'll talk a little bit more about what we do now. We'll be talking about insect-derived protein and its inclusion in aquaculture feed. And before we begin, I'd like to give you a little bit of context about where we're based, which is Dar es Salaam, Tanzania, a beautiful coastal city with over 5 million people looking on to the Western Indian Ocean. But with many cities in Africa, one of its major issues is waste management. And as you can see here, trash is thrown everywhere. There's actually no logistical chain for removing trash out of the city to be placed in landfills or recycled. And it very quickly makes its way into the ocean and our waters. And that's where we approach this problem to begin with. I'd just like to quickly mention, obviously, since we're talking about fisheries and aquaculture here, some of the fishing practices that are still ongoing in East Africa, and particularly in Tanzania, and one of them is dynamite fishing. It's actually still so profound that if any of you were touring the region and scuba diving, there's a very good chance you'd hear a boom underwater, which is quite scary to think about, how much of that coastal reef is being destroyed. So who are we and how did we begin this project? This project actually began with Matthew Hayden. The man is extremely passionate about waste management and recycling, and he started a recycling business in Tanzania, of all things, 4 to 5 years ago. And when he looked at all the organic waste that was being placed in landfills, he saw black soldier flies as a potential way of removing that waste. And that's when Matt and I started talking. I'm a veterinarian by profession, and I'm actually a poultry specialist. Aquaculture is relatively new to me, so forgive me when I get things wrong here. But about 2 years ago, I started dabbling in tilapia, and then I founded Indian Ocean Aquaculture. And I partnered up with Matt to be able to take black soldier fly larvae and formulate it in a feed that we could use in the region. So this is the innovation, and it's not something new. This is black soldier fly and its larva, Hermertia lucens. And people have been working with this fly for about 2 decades as one of the front runners in insect-derived protein and really looking to displace fish meal and soybean in aquaculture, poultry, and pig diets. There's been a lot of limitations of how it's been done around the world, and we haven't quite gotten to commercialization. But I will talk about why we believe in the East African context, we can make a lot of that ground. This is a video of somewhat close to that finished adult larva there. We harvest them when they're still white before they get to the dark larval pupa stage, where they're about to turn into the fly, and that's because we've measured the nutrient profile of the larva at different stages, and just before they go into pupation stage is when we're getting the most out of that larva. And the kind of peat or dirt you see around it, that's essentially now processed organic waste. It's mostly larva poop. I'll talk to you briefly now about the process of producing this larva. So, like any livestock or farming process, there's breeding and then there's grow out. What we have here on the left are dark cages. So you place the pupa in there. It then pupates into the fly. We then tunnel the fly into what we call love nests, where they sit and mate. The adult fly doesn't feed, it mates, it lays eggs, and then it dies. And Matt struggled with this stage, and it was actually really interesting seeing him spend, well, most of his time thinking about fly sex and how to get around the problem, because they just weren't producing enough eggs. And he did finally crack it. I don't know how. I'm not sure I want to know how, but I'm sure it involved a lot of experimentation. But finally, we've gotten to the stage where each of the female flies is producing at around 300 eggs in one batch, and then it dies. From that love nest, we then harvest these eggs. They're attached to these balls that we place in the love nest. We then hang them over these trays. They fall. When they hatch, we then feed them a basic feed for the first 5 to 7 days. They're then sorted, counted by weight, and placed in larger trays where they're fed for another 12 days. So the process is quite quick to get to the adult maggot, about 17 to 19 days in total. And during that period, the larva will consume about 10 times its weight. And I'll talk about that shortly. Actually, I'm going to talk about it now. 100 tons of waste will produce about 5 to 10 tons of larva. And at the moment, we are still a very young business. We started it in January this year. But we're hoping within about a year and a half that we'll be producing 3,000 tons of it annually. I understand that's still a very small dent in the global feed production industry, but for East Africa, it's reasonable, and we're hoping to grow from there. And just a little bit there about the system's impact. So what we're doing is we're creating a few things. So we're removing organic waste that would otherwise be going to landfill and then producing greenhouse gases, and we're turning that into a better form of fertilizer. What we're also producing is two products. The flaked dry maggot product that we'd use to substitute fish meal and soybean in feed, not completely, but partially. And also a larva oil product, which is taken from the crushed larva. And this can, again, be used in animal feed products for range, not just aquaculture, but poultry and pigs as well. Direct user impact, and it's important to remember that I'm talking about this from an East African context. A 10% reduction in feed cost is, I know, sounding exaggerated, but in East Africa, where feed, a basic tilapia grow-out feed is going at above $1,000 per ton, that reduction is possible. And the way we see it happening is that we're competing directly with soya and fish meal. Soya in East Africa is going at about $600 per ton, and fish meal is going at about $800 a ton, and we're hoping to be priced in between that. But more importantly, we'll provide year-round stability in feed cost. How's that? Most of the other raw ingredients that I've just talked about have seasons and particular harvests during the year, and so as such, there's fluctuations in the price through the year. So feed millers will have to buy at the cheapest point of that year and then store product. This obviously greatly affects cash flow and adds risk to the business. What we're saying to feed millers is that we can produce black soldier fly year-round in our perfect tropical climate to meet their requirements. So there's no need to put in massive cash injections for that raw material at particular times of the year. And then finally, we're hoping to use that to build the overall aquaculture industry, because feed is probably the most important bit for building the industry as a whole. This is a short slide here on improving livelihoods, and I wanted to just draw this link because we're depleting those coastal oceans around East Africa, and people's livelihoods are being put at stake at this. And that flux between fishermen and farmers is something I think about a lot, and being able to add to the industry, we'll be able to pull some fishermen back and provide other forms of livelihood for them. This is where Indian Ocean aquaculture comes in. My business on the left there, you've got Dula, who you just saw in the previous picture, with Rashid working on some recirculating systems. We'll be testing the formulated fish feed in there, taking the tilapia up to 1 gram, and then further in our ponds where they'll be grown up to 500 grams. The challenges ahead are similar to any new business or product that's trying to enter the market, and that's in scalability, which I see has been misspelt there. The cost effectiveness of that final product, and obviously at the end, convincing feed millers and farmers that our product is viable. Finally, I'd like to say thank you to a range of organizations that supported us over the last year and a half, particularly DFAT, the Australian government. We were fortunate enough to win the Blue Economy Challenge last year, which has helped build that business. And thank you to you for giving me the time to talk to you about this. Finally, that was obviously a very brief presentation on black soldier fly. If you'd like to be in touch with Matt or myself, please do, and obviously I'll be around for the rest of the conference to answer any questions you may have. Thank you very much for your time.